Hi, hello everyone. My name is Teng. Today we're going to introduce our design of experiment, effect of temperature, agitation, and the sugar type on rate of solubility in the water. Our team have Qianyi, George, Shivam, and Teng. So here is some introduction of a background. We're gonna dissolving sugar cube in hot water and using design experiment to find out the factor effect. Similar industry application is using in medical industry that we try to understand the rate of medicine that is dissolved and how effective it is. So our goal was going to measuring the dissolving rate and apply the design of experiment to find out the factor of effect. And then we're going to start the interaction effect of each factor.
The main focus of this experimental procedure is to capture the rate that the sugar will dissolve based on the input parameters. To ensure a consistent process, the weight of the sugar for each test was 3.6 grams, the height of the apparatus was 8 inches, and the volume of water used was 200 millimeters. We used a heating plate apparatus to maintain constant water temperature throughout the experiment. We also used a magnetic stir bead to conduct the agitation test and a digital thermometer to capture the water temperature. We use two different types of sugars, brown sugar and white sugar. It can be observed that brown sugar has a higher density than white sugar, which could also be a factor in the dissolution process. The first step was to set the heating plate to the correct temperature. The low setting ensured a water temperature of 70 degrees Celsius, and the high setting ensured a water temperature of 100 degrees Celsius. 200 millimeters of water was then poured into the beaker to heat up. Before each run, the water temperature was checked using a digital thermometer. If the temperature held for more than 5 seconds, then the run was conducted. For agitation tests, a magnetic bead was placed in the beaker and the stir speed was set to a low setting. The timer would start at the same time the sugar was dropped. The timer would stop after the test conductor observed that all the sugar was fully dissolved. Here we have a video showing the agitation test being conducted. We used a digital thermometer to take measurements of the water prior to testing. We made sure that the water temperature stayed consistent to ensure that the water was evenly heated throughout the entire test. The process was measured subjectively using a stopwatch after the sugar specimen was dropped into 200 millimeters of water. It is good to note that the test conductor is only stopping the stopwatch after visible inspection that all the sugar has dissolved. There is a possibility of human error being involved, especially during the agitation test, where the sugar visibility is reduced due to noise.
We had a 2 to the third factorial design. The three factors were temperature, whether or not the solution was agitated, and the type of sugar. The temperature was either set to 70 or 100 degrees Celsius and maintained via hot plate. The agitation was created by a stirring plate, and the two types of sugars used were brown and white. A total of 24 runs were conducted. The model summary in respect to the regression equation shows that the data fit in the models have a pretty good fit. As shown in the adjusted R-squared, we have about a 95.66% fit. The 4 and 1 chart of the residual plots show the adequacy of the model. Most of the points correlate with each other, but in each plot we can observe an outlier which slightly skews our results. Within the versus plot, we can see a trend where a fitted value or the observation number increases, the residual begins to grow and scatter more rather than stay consistent.
In our analysis of variance, there was a total of 23 degrees of freedom, one for each factor, one for each two-way interaction, one for the three-way interaction, and 16 for error. From the resulting p-values, it is observed that each factor as well as each interaction is statistically significant given their p-values of less than 0.05. However, from the f-values, it is evident that temperature and agitation are by far the most significant. In fact, the interaction between temperature and agitation is more significant than that of sugar type alone. To better illustrate the significance of each factor, a Pareto chart of the standardized effects is used. The Pareto chart lays out each factor and interaction in order of its effect on the response variable, dissolution rate. Note that the dashed red line at 2.12 is a threshold for significance given our alpha value of 0.05. As previously mentioned, each term surpasses the threshold for significance. However, it is clear to see that temperature and agitation have the most effect on the response variable, with agitation having a slight edge over temperature. The factor effects plots show how each factor affects the response. The factor effects plots show how each factor affects the response variable. In the main effects plot, we see that temperature has a negative linear relationship with dissolution rate. In other words, as the temperature increases, the dissolution rate decreases. Agitation and sugar type are both categorical factors and can only affect dissolution rate in one of two ways. As such, we see that dissolution rate is lower when agitation is used, and also lower when white sugar is used instead of brown sugar. The interaction plot illustrates how the interaction between two factors affects the response variable. In the interaction between temperature and agitation, we see that the effect of temperature is most variable when agitation is not used. Similarly, temperature is more variable when brown sugar is used instead of white sugar, though not as much as with no agitation. The interaction between agitation and sugar type is not very strong, evident by the nearly parallel lines in the plot, though again, the use of white sugar still results in a lower dissolution rate. From our model, a contour plot was created to illustrate the relationship between our most significant factors, agitation and temperature, and our response variable, dissolution rate. It is evident from the plot that the use of agitation and higher temperature values yield lower dissolution rate.
Adding the response variable as a third dimension gives us our response surface plot. From the surface plot, we can see that there is a high degree of variability from temperature when agitation is not used. In turn, when agitation is used, the variability from temperature is significantly reduced, showing that agitation is indeed the most influential factor on dissolution rates.
So here is our conclusion. From the factorial design, the sugar dissolution was most sensitive to the change in agitation. And also, we also confirmed with the interaction plot, which using the agitation has most effect on fast solubility in water too. And thank you everyone.
Here are our references. We added this backup data in order to show that our run order and our standard order were different, and this last column actually shows the times that we recorded. Thank you.
Finally, a cube plot for dissolution rate was used to illustrate how dissolution rate responded at each corner of the factorial design. From the cube plot, we can see that dissolution rate is highest when using lower temperature, no agitation, and brown sugar. If we wish to minimize dissolution rate, as would likely be the case in a real-world scenario, the cube plot indicates that a higher temperature, the use of agitation, and the use of white sugar would yield optimal results.
Next, we have a few residual plots that we did not include in the actual presentation. These are considered also backup data.